All right, let's dive into one of the most amazing stories in all of modern physics. It's about a revolutionary idea that wasn't born from some flash of genius. Nope, it came from a simple and very, very fortunate mistake.
I mean, think about that for a second. What if a simple slip-up could completely change how we see reality? Well, that's exactly what happened here. And to really get it, we have to rewind the clock a bit. So, to understand why this was such a huge breakthrough, you have to understand the problem everyone was stuck on. Back around the year 1900, physics was kind of hitting a wall. The old classical theories worked great for things you can see and touch, but for the tiny stuff, they just broke. Especially for this one nagging problem called black body radiation, basically trying to explain why things glow when they get hot.
A guy named Max Planck got the ball rolling. He suggested that maybe energy comes in these little packets or quanta. But even with that, a massive piece of the puzzle was still missing. The normal way of doing statistics, the math they used to predict group behavior, it just didn't work for tiny particles like photons. And that brings us to 1924 and a pretty normal lecture hall in Dhaka.
This is where we meet our hero, Satendra Nath Bose. He's teaching a class at the University of Dhaka, trying to explain why the old theories were failing. And right there, in the middle of his derivation, he makes a mistake, a big one.
The key word there is unexpectedly. I mean, this should not have worked. By all the rules of statistics, his result should have been complete gibberish. But instead, his wrong calculation perfectly matched the real-world data. The very same data that had been driving physicists crazy for years. He realized maybe this wasn't a mistake after all.
So what was this error? Well, the best way to think about it is with two coins. Classically, we'd say there are four possible outcomes, right? Heads, heads, tails, tails, heads, tails, and tails, heads. We count those last two as different. But in his mistake, Bose basically treated them as the same thing. To him, getting one head and one tail was just one outcome, not two.
And this is the absolute genius of the whole thing. Bose realized that for quantum particles like photons, you literally cannot tell them apart. They are fundamentally perfectly identical. There's no difference between photon A and photon B. So his counting method wasn't an error, it was a brand new and totally correct way to count things that are truly indistinguishable.
So Bose writes up this incredible insight, sends it off to a journal, and it gets rejected. But he didn't give up. He mailed it directly to the biggest name in science, Albert Einstein. And Einstein, he got it instantly. He saw the genius, translated the paper into German himself, and made sure it got published, putting his own massive reputation behind this wild new idea.
Now, Bose's idea didn't just solve one nagging problem. Oh no, it cracked open a whole new way of looking at the universe. It turns out the subatomic world is split into two completely different families of particles, and it all comes down to how they behave in a crowd.
The particles that follow Bose's new rules are called bosons, in his honor. You can think of them as the social butterflies of the universe. They love to clump together in the exact same state. There's no limit. Their opposites are the fermions. They are totally antisocial. They live by a strict rule that says only one of them can be in a certain state at any given time, no exceptions.
And this one difference explains so much. Photons, the particles of light, are bosons. That's why you can have a laser. It's just a bunch of photons all crammed into the same state, acting as one. On the other hand, electrons, the things that make up atoms, are fermions. And that's why solid matter exists. It's why you can't just push your hand through a wall. The electrons refuse to share space. Einstein didn't just give Bose's idea a thumbs up, he took it and ran with it. He thought, okay, if this social behavior works for photons, what about for certain atoms? And when he did the math, he predicted something truly bizarre, something that shouldn't be possible. He predicted a fifth state of matter. We call it a Bose-Einstein condensate. The idea is, if you can get a bunch of bosons cold enough, we're talking fractions of a degree above absolute zero, they will all just collapse into the single lowest energy state available. They stop being thousands of separate atoms and start acting like one giant superatom. Now, actually making one of these things is an unbelievable feat. Scientists use lasers and magnetic fields to trap a cloud of atoms and just suck all the heat out, slowing them down until they're almost completely still. And as they get slower and colder, their quantum nature just takes over. Their wave functions literally expand, overlap, and then merge into a single unified quantum state. For 70 long years, this was just a theory, a ghost in the equations.
Nobody knew if it was real. Then, in 1995, two physicists, Eric Cornell and Carl Wieman, finally did it. They cooled atoms down to just billionths of a degree above absolute zero, and they watched as the atoms condensed into that single quantum state. After 70 years, Bose and Einstein were proven right. So, okay, this is all really cool for a physics lab, but why should you care? Well, because understanding this social nature of bosons has completely changed our technology and our world.
You know that laser pointer you use for presentations? That's just a stream of photons, all behaving like good little bosons, acting in perfect unison. That mind-bending phenomenon of superfluidity, where liquid flows without any friction, that's bosons at work again. And looking forward, things like quantum computing are being built on these exact same principles.
So really, the big takeaway is this. What started as a counting mistake in a classroom revealed a deep and profound truth about our universe. The idea that some particles are identical and social wasn't just some minor detail. It was the key that unlocked a whole new state of matter and technologies like the laser.
It really makes you wonder, doesn't it? If a simple error led to all this, what other incredible secrets are just waiting for us to stumble upon them, hidden right there in plain sight?